recording here. So section 6.5 deals with the average value of a function. And I want to just bring up quickly the ebook on this. So, you know, you're seeing a lot of applications in chapter 6. And in Thursday's class, you know, so Thursday we will have class. And of course, I'll post the exam after the class. And also, I'm going to make a new orientation quiz for you. But we will have class on Thursday. On Thursday, we're going to talk about work problems, applications to some physics and engineering applications. But right now, I want to just mention here average value of a function. So really, how many have like seen on the news where the news person, the meteorologist will say the average temperature today was this, the average temperature this morning was this temperature? How many have seen that kind of phrasing like on a news show? Sure, Justice knows what I'm talking about. And you know, so you might wonder, well, how are they getting the average? How are they getting the average? Well, you know, to get the average of a collection of values, you know, you take the values, add them up, and divide by n. Well, if we wanted to, like, if we have a temperature function like they're showing here in figure 1, a temperature function, and notice like it goes from 0 to 24 because there's 24 hours in a day. And between like 0 and 6 a.m., it's colder. And then as you get like at 12 would be 12 noon, it gets hotter. 18 would correspond, that's military time, that would correspond to 6 p.m. It gets, you know, the hottest, and then it dies down between 18 hours and 24 hours. So, you know, we can model things with a temperature function. But we'd like to be able to find the exact average based on the temperature function. And so what you can do is the temperature function, you can take values of the function, add up the values, and divide by n, and that's going to get you an average temperature, okay? But the n is the number of temperatures you take. And since delta x equals b minus a over n, then you can write n as b minus a over delta x, like they show you here. And if you then rewrite this expression, you'll get the average temperature or average value of the function as 1 over b minus a times the summation of f of x delta x. Well, naturally, if you take more and more values, if you let n go to infinity, if you take more values of your function, then this Riemann sum will become the integral. And this is how you get the average value of a function. That's how you get the formula. Okay, so and you can apply that formula in a variety of problems, and you'll see it's easy to do. And so that's basically, but I like to think of this formula in terms of average temperature because it's the easiest way for me to think about the formula, an application of it. But you'll see in your homework that you're going to have other applications of the average value of a function. Like for instance, if you wanted to find the average velocity of blood that flows through a vessel, okay, that's a medical application. Okay, or if you wanted to find the average density of a rod, I'm not sure that, well, that's another application. But, you know, so this is really all I wanted to talk about on section 6.5. I think you'll be comfortable with that. Are there any questions on that? How many think it's kind of a cool application? I certainly do. Okay, thank you, Justice. All right. He's like, Snega likes it. Adriana, yeah, it's absolutely. Thank you, Adriana. And Snega, it's absolutely cool. You know,